going on, everyone? We'll start in just a second here. We'll be talking about Arduino today. So it should be pretty fun stuff. Here, let me go ahead and get this out of the way. Okay, enough of the peppy music. Time to get down to business. What's going on, everyone? My name's Zane. I'm a coach here at MLH, streaming to you guys for this Global Hack Week, Beginner's Week. Fun stuff, fun stuff. We are going to be going over Arduino. So for those who don't know, Arduino is essentially a little like computer circuit thing that you can, it's called a microcontroller. You can basically learn how to build circuits and learn how to make like little electronics projects, and also use like programming and coding to make more complex projects, more versatile projects. So we got some people in the chat. Hello, hello. Nice, nice. Okay, so before we really get started, make sure you all jump in and register at this link here, just to help with our attendance here. Without further ado, I'm curious too, how many of you are familiar with Arduinos or just microcontrollers in general? Like, have you done stuff with Raspberry Pis or anything of that nature? Been doing it for a long time. Nice. Yeah, I've told people on past streams I've done before, but I've mainly done web development. I'm beginning to Arduino recently, now that I've gotten more of an interest in electronics, embedded systems, stuff like that. So relatively new to the Arduino stuff, but I have been learning enough to, I know enough to be dangerous, you could say. It's always a fun place to be. Raspberry Pi, nice. A little bit, perfect. Yeah, so hopefully this will, well, this should be a pretty nice little stream, getting us all situated in here. Okay, so I am going to, here's the plan. So there's a website known as Tinkercad, which we are going to use to emulate an Arduino software-wise. So let me show you all this website. It's pretty cool. Let me share my screen. Never heard about Arduino. Nice. Yeah, this should be pretty fun. I've had a lot of fun with it myself. My school has a makerspace, which is like this room with all sorts of different hardware and software stuff to play around with, different microcontrollers, VR headsets, like little robots. So I've gotten my hands dirty with that quite a bit. It's pretty fun. Well, with this, let's go ahead and share my screen, and we'll jump right into this. I'm going to do an entire screen share. I talked with, well, the stream that I did the other day, I usually don't share my whole screen because, I don't know, I just think the production quality is a little bit weird if you do that. But I did a stream the other day where people really liked it, so I'm going to give that a shot. That way I can also like easily hop between notes and the like. Oops, hold on, my computer's screaming at me. Okay, so share my screen. Entire screen. Oh, share system audio too, nice. Okay, cool. Okay, so let's put this up on screen. Boom, boom, boom. Okay, so you should be able to see my screen now. So this is Tinkercad. It's essentially a website where you can just learn about all sorts of stuff, including like circuits, as well as like how to use like Arduinos and different microcontrollers. So it actually has an Arduino like emulator that you can just use and learn with. So I have this pulled up. I also have some personal notes of just stuff that I've made going through. I have the Arduino projects book that we can refer to if needed, as well as just some simple notes with really hyper condensed, just things to know. So I actually learned Arduino mainly with the physical unit, but I wanted to try this out just to see how it holds up. So Arduino basic kits, learn about the Arduino platform, set up your kit, interact with circuit simulator. Okay, let's see. Okay, nice. Electronics. So Arduino is going to help us with electronics. Everyone from all backgrounds, learn how to use it. Been using all sorts of different projects. Open and simple. Okay, so basically you can do beautiful things. Make someone smile with your Arduino. That's always good. That's what we're after today, folks. Arduino makes it easy to program tidy computers. Really hope we do get some smiles in here. We should be able to learn some cool stuff. You're surrounded by dozens of them every day. Microcontrollers. So you are surrounded by dozens of them every day, embedded in timers, thermostats, toys, remote controls, microwave ovens, even some toothbrushes. This is what really interests me about this stuff. So I was in web development before, but I just realized I don't really care about pure software, pure internet, all of that. Things that interface with the real world and that can affect the real world, I find so much more fascinating. They do one specific task, you hardly notice them. Okay, so yeah, this is one of the main. This is getting into some of the concepts that I took note of as well. I guess just good vocab to know. Transducers, which is something that changes one type of energy or other types of energy into electrical energy and vice versa. Sensors, other types of energy into electrical energy. Actuators, electrical energy into other forms of energy. So sensors and actuators are both transducers. Sensors go from other energy to electrical, actuators, vice versa. Just good terminology to know, because that's kind of what we're going to be dealing with here with all this electronic stuff. As you'll come to see, everything is about it's about that, really. At least if you want to do anything interesting. Let's see. Sensors listen to the physical world. They convert energy that you give off when you press buttons. And then, okay, so sensors, actuators, as we talked about. Microcontrollers listen to sensors and talk to actuators. And yeah, I mean, it's even in the words too, like sense, you're going to be sensing something that you can then convert to electrical energy. Actuators, you know, I don't know, what's the etymology there? They kind of act, I guess. They take electrical energy and they do something in the physical world that's not electricity based. So microcontrollers listen to sensors and talk to actuators. They decide on what to do. Let me just keep up with the chat here too. Intro to X. Yeah, that was, I mean, it's kind of like X as a variable. I was given free reign over what I wanted to do. So I chose Arduino. But yes, we will switch that to Arduino. Let's see. So I took a course that involved Arduino programming in my first year. I'm an electrical and electronics engineering student here. Nice. Yeah, honestly, I switched my major for computer science to electrical engineering. I plan to be very software focused, but I don't know. It's just fascinating stuff. I use an Arduino to build a digital precision clock. Interesting and easy to build. Nice. There's a lot of fun projects, man. I'm in Tinkercad, but can't find that welcome to Arduino page. Yeah, let me show you how we can get here. I think you go to, let's go to the home page. So we have this stuff, my designs. I think you go to projects. How do I get here? Resources. How did I even get here? Weird. Here we go. So under Tinker. So if we go here, or if we just on the nav bar on top, if you go to Tinker, you go to circuits, add light movement to your design. I guess this is just the landing page for it. Oh no, so if you scroll down to get started, there's a lot of stuff before it. The Arduino, I mean, this stuff just kind of talks about like electronics concepts in general, which of course is good to know. But the Arduino, if you click on it and you scroll all the way down, eventually you'll come across the Arduino specifically. This is like the Arduino being used in terms of the general electronics curriculum. But keep scrolling down and you'll have this, like this thing here, Arduino Project Zero Introduction. In fact, I don't know if I can send you guys the URL. I can try. I'll try and post it in the chat. Let me know if it works. So the Arduino, this should still introduce like all the basic electronics fundamentals that you see like on that other screen, just within the context of the Arduino. So anywho, So we're talking about actuators and sensors, right? They're kind of the things that really make your interesting projects work, if not just make the whole thing work as a whole, the microcontroller. Microcontrollers listen to sensors talk to actuators. They decide what to do based on a program that you write. Yeah, so we can actually use code with this as well, as we'll see coming up. So take a look at the project to the right of this panel. Click on the Start Simulation button and give the knob a turn. Knob, this thing? Oh, I have to press the Start Simulation. So the motor turns with it. The Arduino is collecting information from knob called the potentiometer. This thing here? Oh, where's my knob at? So servo, I'm guessing that's a motor. That's a potential. Yeah, so that's a potentiometer. So that should be a button. Just don't know why it's Start Simulation. Okay, initializing. There we go. Okay, I just had to start the. Thought I did, but oh well. Interesting. Okay, so there we go. We're moving something. Oh, so I guess it just kind of follows the position of it, or no? Interesting. Okay. Anyways, you get the point. So the motor turns with it. The Arduino is collecting information from the knob called the potentiometer. So potentiometer is just like a kind of like a volume knob, right? You have a whole range of values, translating it into motion in the motor. This is a project that you will actually learn how to build with the Arduino Basic Kit. Okay, the mood cue. Can you think of some more examples of sensors and actuators? Okay, that's a good one for everyone in the chat. Sensors and actuators, what stands out to you? What comes to mind? There's a hint down there. I'm not going to give it to you all, though. Microcontrollers and electronics you attach to them are just the skeleton of your projects. You'll need to apply skills you probably already have to put some flesh on the bones. So in the mood cue, you'll make an arrow and attach it to the motor. Oh, nice. This would be fun, honestly, to like, oh man, I should probably do this for school. I have my coding club that I run. It's actually starting up this week again. Classes are going to be back in. And we have all sorts of departments like that would love to collaborate with us. This would be like cool to do with the art department, actually. I want to keep that in mind. Ooh. Fun stuff. Anywho, so you can make a meter to tell people whether you're busy or not. And another, you pull some lights and a tilt switch on a cardboard frame to make an hourglass. Oh, nice. Arduino can make your projects responsive, but only you can make them beautiful. Isn't that true? That is, I know that from making music. Arduino was designed to help you get things done. The basic kit, keep the programming, the background material, and programming electronics to a minimum. Oh, nice. So it has some resource kits. Okay. Nice. Okay, so parts in the kit. You completed this lesson. We'll kind of see what it talks about. I know that at least in the handbook, like very, very early on, it gives you all of these different components to know about. But I don't think it's that useful to learn about all of them all at once when you haven't, like, if you aren't building anything with them actively. So it's good to know that this resource is here, because it becomes a lot more meaningful when you're actually working on a project. It's like, oh, okay, well, I have to use like this thing and this thing and this thing. So what exactly are these things? And then you can go back and read it. I don't know, just personal philosophy. I found that a lot more engaging. Okay, let's see. So we've got photodiode sensor. So photodiode, that would be like something that reacts to sunlight, right? Or just any sort of light, really. An LED will be an actuator. Yes. So LED is, right, because it takes electrical energy and it converts that to light energy. Perfect. Okay, so going through parts in the kit. So you'll get to know the components in your kit. We might not go through all of these. Again, I want to focus on the ones that we'll actually be using first, because it's just a lot more meaningful. to do so. Okay, pre-cut, easy to assemble wooden base that will make working on all your projects even easier. We use communal Arduinos at my school where everyone can use them. I don't know where our wooden bases went. So I don't know. It's not really the most important thing. It's not required whatsoever. Just kind of set your breadboard and Arduino in it, as far as I know. Okay, so your kit comes with a large variety of components. Arduino Uno, this guy here. This is the star of the show. Your breadboard, which is this thing here, this like beige thing. This is where we're gonna work with our electronics. I'll kind of explain all this in just a second. Yeah, like all this, like you don't have to know all this stuff as right now. But it does point out a good detail. So we can access all of our components on the right-hand side here. You can see. So we can see, like, you know, it lists this stuff. Battery snap, where's it at? There's different batteries and motors, diodes, stuff like that. Yeah, we're going to focus on what we actually need to know for each project. So wires, the last component is not found in the components and menu. Okay, yeah, wires, you can like click on here. Well, I'll explain in a second like what exactly this is. Okay, nice. So basically, it's telling us to connect our Arduino from power to the board, from ground to the board. Let's see. And that will connect our Arduino to the breadboard. So I don't want to go into like what exactly is going on here conceptually just yet. I'd rather wait until we have like a real project in front of us. But you can like place wires down to connect the Arduino to the breadboard. The breadboard has like strips of metal running through it that carries the current, because this supplies an electric current, flows through here. Then you can like connect the wires all over the place with different like components and blah 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 blah. Not exactly like that, but you kind of you'll see once we get through it. It's preferred to use a red wire for things running through power, black for things that are like conceptually related to what you want to be connected to the ground. So we'll see all that in just a moment. And yeah, you can change the color of your wires, which is nice. So parts of the Arduino power connector, this right here. Well, it's not plugged into a USB port for power. Accept voltages. Okay, I mean, not crucial to know stuff. Well, I guess it is a little bit important what voltages, but I don't know. A lot of times, at least from what we've done, like with my limited experience with Arduino, I've mainly done stuff with, especially like if you're interested with coding with it, and you're basically going to be using a USB. Because that way you can connect to your computer, you can run software from your, IDE. So reset button, simulator, your board isn't acting the way you expect. And then what are these guys? Those two LEDs. Indicate communication between your Arduino and your computer. So yeah, I mean, this stuff is important when you actually have a physical one, a physical Arduino that you're working with, but we're just using a software emulation, so we don't have to worry about it. Digital pins, binary data, interpret range of, yeah. This sort of stuff I'm not worried about right now. Again, it becomes so much more meaningful when we actually are working on something. So ATG, Mega, this is the brain of your Arduino, apparently. Power LED indicates that your Arduino is receiving power. Nice. Ground and 5-volt pins. Yeah, so these are the ones that we're going to care about at first, because we're going to use those to supply powers. The basic projects at first just work with like LEDs. Things you need to supply, like a flashlight, conducive material. This is for like the more artsy side of it. Okay, continue. Let's get to a real project here in a second. And this is good stuff to know, though. So I think I'm just going to skip over this part. We'll come back to this when we need to. Really? Programming the Arduino. Okay. Build a simple circuit. Okay, this is what we want to start with first, honestly. Then we'll come back to the coding stuff when we actually need to know it. Okay, so going through. Oops. Wait. Build a simple circuit. Access rate exceeded. What? It logged me out of my account. That's weird. Hold on. Oh, give me 1 second. This is the weirdest error. Okay, Tinker, circuits. Start simulating. More tutorials. There shouldn't be. Everyone that I've known that's used this hasn't had issues just using it indefinitely. Build a simple circuit. Okay, here we go. Here we go. We've got it working now. Share screen. Entire screen, we can do this. Okay, so now we've learned a little bit about the Arduino. We know that you can make basic electronics projects. You're going to be working with actuators, sensors. You're going to wire things up. The Arduino can supply power. The Arduino itself here we can see, and then the breadboard is what we're going to use to like help make the overall circuit, so that we can like have all the components and everything connected in a nice, neat way, as you'll come to see, instead of just like everything strewn about wildly. So I have this learn to build a circuit introduction, getting started with electricity. Is there anything here that we really need to know? Circuit design? No. Okay. Yeah, we can just jump right into the building a simple circuit. So for this is the first project too. I think this is analogous with their project book, actually, because you kind of scroll down and you'll see that they have where's it at? You have a basic circuit where you're just going to be using a button or a switch, an LED, and a resistor. So you're just going to have it to where when you push the button, the LED will shine, and when you let go, the LED won't. Pretty basic stuff. Let me give some concepts, things to know about. We'll definitely walk through this stuff ourselves, but I want to get our hands dirty with it a little bit first. So, okay, goes into, right. Cool. Okay, so we'll kind of just focus on this more condensed version here. So since we want to hook up an LED, we're going to have a power source, which the Arduino can provide, this 5-volt. So you want to use the Arduino on this project, but only as a power source. When plugged into a USB port or 9-volt battery, the Arduino will provide 5 volts between its 5-volt pin and its ground pin that you can use. So essentially, we can use the Arduino to power the LED. 5V for 5 volts. Let's see. So in the circuit schematic shown below, a button is used to create and break a connection that allows current to flow through the LED and resistor. Okay, so let's see. So we can see that. So this is the Arduino unit as it's labeled. Here's the power. I mean, this is like a simplified schematic too, right? It's not going to look exactly like the Arduino, like our board will. But it just kind of shows very straightforward conceptually what's going on. We have the 5-volt, the power going in. And that is going to go through a resistor, which I'll explain in just a second. The electricity, the circuit, is going to go through the resistor, which I'll explain in a second. Then you have this button here. When the button is not pressed, the circuit will not be completed. And when the circuit's not completed, then there's no way for the energy, for the electricity to reach the LED here. So it's not going to shine if the button isn't pressed. But when it is pressed, then you can make your, then you complete your circuit so that the energy flows, everything goes all around, and you'll have power to your LED. So I'll explain how a circuit works and all in just a moment. There's a little bit of concepts that we could use to that'll be helpful to know, but we'll touch on that once we have like a concrete example to relate it to. So let's go ahead and build this basic circuit. So just physical kit stuff. Plug any battery or USB cable connected to the board when you are building the circuit. Should not be receiving power. Okay, so important thing to know is, do we want to get into this yet? No. Provide power to the breadboard, voltage rails, horizontal rows at the sockets. Keep your wire color consistent. Red for power, black for ground throughout. Okay, so essentially what we're going to do is kind of similar to what we did just a few minutes ago. We're going to wire this up, and I'll explain to you why. So to have a circuit, which is, let's bust out some terminology here. So a circuit, closed loops of wire with a power source, like a battery, or in this case, our Arduino, and a load, which is something to do with the energy that's useful. So in our case, I guess we're going to power our LED. So notice how it says a closed loop of wires. So just a couple things to know. We will be building circuits to move electricity through different components. In a circuit, electricity flows from a point of higher potential energy to a point of lower potential energy. So high to low flow. So what this means, this 5-volt has higher potential energy than, say, this ground that we're going to connect up. So what's going to happen is we're going to have components on this board in just a second where this higher energy is going to go through to like an LED, for example, just kind of arbitrarily placing wires down, just to kind of show what's going on. So that'll be connected to there, and then this will connect to the same strip as the ground. So you can see how there's like a path that's going to be traced. You start with your high energy here, the 5-volt, goes along this red wire, and then it's going to go through like components on the board in some way, and then that's all eventually going to come back to this strip here, where the energy like travels back up to this black wire, where it goes down to this to ground. And ground has lower potential energy than the 5-volt, where the power is being supplied, right? So this is that closed loop sort of thing. Or we could do, this is that concept of the closed loop. So you need a loop for the circuit to work. It's not enough for there to be a dead end. It just doesn't work that way. I don't know why. It just doesn't. So we have power, or 5-volt, grounds. So, and then there's different types of the way the energy flows. The types of circuits that we're building are direct current. So electricity only flows in one direction. So you can see that, right? How we're going like all the way around. This sort of stuff we'll touch on in just a second. But a little bit about the breadboard to know. Let me just keep a little chat too. Make sure you guys are saying anything. Okay, so thing to know with this as well. One final thing about our breadboard here is just what exactly how this breadboard is laid out and what exactly is going on here. So these long strips here on the side, these are long strips of metal that are working just like this. They're going horizontally, like relative to how we're looking at it. It's just a long strip of metal. And the same thing with this one. It's just a long strip of metal. So like this is like the positive strip of metal, but there's nothing like, that's just to keep things organized, right? A strip of metal is a strip of metal for this Arduino. You could use either. You could swap them around with how you're connecting your wires. But it's just it's labeled this way just to keep things consistent so that, you know, with all the benefits that consistency brings. These ones here, these are, at least from how we're viewing it, vertical strips of metal. And the reason why these strips of metal are important is because this is how the current is going to flow. So when we have this red wire going on to this strip here, well, now this entire strip is kind of like activated to where we can then continue off of it to go to, like, say, right here. So now like this first strip here in this area is now like activated. And then if we go like here, now this like 10th strip is activated. If we connect it to there at least. So now this whole strip is activated. So you'll see exactly what this means once we actually start building the circuit itself. Just some pretty important like prior knowledge to be aware of to just understand how this is all going on. Just understand like how this is all functioning. So let's continue with this. Let's do their explanation of it. Okay, so add the LED and the button. Now that you have power on the board, you can place the button and LED. The button will sit across the center in one direction. In your kit, the bend and the button legs point to the center of the board. In the simulator, the button is already oriented the right way. Okay, cool. When assembling circuits, you can use the picture directly as a guide or follow more specific instructions below. Okay, so let's see. The nice thing about this breadboard is that it's actually labeled with like where exactly you would put these exact pins. So this button, this leg at least is going to go in E8, the LED to E13, or this left leg of it at least, E13. Okay, so let's get our button E8, LED E13. You don't have to be that exact. Like it doesn't have to be E8 specifically, and this doesn't have to be E13 specifically. It's going to be like how your wires and the like are set up. But we'll just follow this as it has it. That way we can like easily troubleshoot against the picture versus ours if we run into problems. Like we don't have to mentally adjust for things being arbitrarily different in our setup. Okay. So yes, the LED legs are important, the cathode and the anode. So how an LED works, how one of these works at least. An LED is a polarized component which only allow electricity to flow through in one direction. So we have to make sure that our, let's see. So our anode, our longer leg, connects to power. So that's this one here. You can see it's bent because when you, it has a longer leg to it, so you can like see which one is the anode versus the cathode, because these are both just like, you know, metallic little like pins. You can't really, you can't differentiate one from the other like right away. So they make this one longer. This is the anode. This one has to be connected to power because, again, an LED is a polarized component, and electricity can only flow through in one direction. We can't hook it up the other way or it's not going to work. So we're going to have to hook up the power to the anode, this longer leg. We'll have to connect the ground to cathode. So when the voltage is applied to the anode of the LED and the cathode is connected to ground, the LED emits lights. As we said, when voltage is applied to the anode, so this one connects to power, and cathode connected to ground. Oof, jumping around on me. LED emits light. So let's start to set that up. We have this in place. Oops. E8, E13 we said. So eventually, in some way, this is going to go here. Or we could even do it. We don't have to connect right there. We could go like here to here if we want to do it most directly. But that is going to cause some issues. It should work. Right. Okay. So let's kind of see what's going on here. So this isn't how you want to do it. but it will make our LED shine. So why exactly is that? Let's kind of run through let's run through what's going on here. And just make sure. Let's see. I think there are meters in the component list. You could use the voltmeter for parallel sensing of your circuit. Measure if the current is working properly. Yeah, definitely meters can be your best friend. Application used to have the capability. Okay, nice. There used to be a button that would draw a schematic of the virtual circuit that you put together on the screen. That sounds pretty handy, actually. I'll have to look into that. Hello, hello. What's going on, 404? Nice. Okay, so now this works. The issue, though, is that you're supplying too much energy to your LED. It's going to burn out, and you're going to kill it. But the circuit still works. So we're going to focus on that success first and just kind of understand like why it's working. So as we said, right, a circuit, closed loop, higher energy moving to lower energy. So let's analyze this. Let's see why it's successful. So we have the 5 volt. We have the power coming to this strip here. Now remember that this strip is going to, let me just put this down. Right, so this strip is going to, why is this not working? I guess because that's taking it, I don't know. But anyways, this strip here, right, this is connected horizontally here, as we can see. It's just a strip of metal. So power, the voltage travels along this here, hits the strip of metal, it goes to the next point where it can access, which is this wire here. This wire, as we can see when I hover this, it's now giving the voltage to this strip of metal, which the LED's anode is connected to, right? So the anode is the light that has to connect the power on the LED. Remember that LED's electricity can only flow one way. So this has to connect to the anode. So now the electricity goes through it. But it's not enough just for that. Because if we do this, boom, right? Even though power is connected to it, still is not lighting up because you need that closed loop. We need to connect to ground like it's doing here. Actually, let's see. Let me start simulation just to be sure. Right. So I got no powers going. I mean, power is, it's hooked up to power, but if you don't have that loop, nothing's going to happen. So we have the loop again, because what happens is the energy goes through. Now the voltage is on this metal strip, right? Because this leg of the LED is connected. The cathode is connected to this metal strip. This is connected to this metal strip. It travels along this wire, which then connects to the ground, which connects to this strip, which is ultimately connected to the ground of it's ultimately connected to the ground. And so it just goes on, right? That's why this is a functional circuit. That's why this is a successful circuit. Now, the issue, however, is deals with the concept of resistance. So, and does anyone have any questions on this so far? Does this make sense as to like how this is working? You really can just like kind of trace the pathway here. Let me make sure I'm keeping up. Okay, so anywho, it's in crisscross applesauce right now. Talking a lot. Need some aqua. Okay, so getting back into it. So we see how the circuit is laid out, how it works. But an issue with it is we're supplying too much energy to our LED. Our LED is going to too much voltage. Our LED is going to shine very bright and then die. I think it breaks it if you do that. I've never done it in person because I don't want to break my school's LEDs, but you don't want it to burn out. So what do? We have too much voltage. And this only supplies 5 voltage. It's pretty, it says right there, 5 volts. So what do we do? This is where a resistor comes in. In fact, let's actually talk now about the concepts of current, voltage, and resistance, because that's what's going to come at play here. It can help us understand like why we're implementing a resistor, why this LED would get like blown up, so on and so forth. So, concepts to know. So if I want to, we can kind of just talk on them first. So 3 things that we have to know: current, voltage, resistance. So current is the amount of electrical charge flowing past a specific point in the circuit. And it's measured in amperes or amps. So the amount of electrical charge. Voltage is the difference in energy between one point in a circuit and another. Resistance is how much a circuit, or is how much a resistance, or resistance is how much a component resists the flow of electrical energy. There's actually a nice little visual they have in this guidebook talking about this. So one way to imagine all these, current, voltage, resistance, as it goes on to say, is think about a rock slide going down a cliff. The higher the cliff, the more energy the rocks will have when they hit the bottom. So the higher the cliff, the more energy the rocks will have. So the rocks are the current. The height of the cliff is like the voltage in a circuit. So as it says, just to reiterate one more time, the higher the cliff, the more energy the rocks will have when they hit the bottom. So the rocks themselves are the current, which, as we said, was the amount of electrical charge flowing past a specific point in the circuit. And the height of the cliff is like the voltage in a circuit. The higher the voltage at every energy source, the more energy you have to use. The more rocks you have, the more energy is being carried down the cliff. So the more current that you have, the amount of electrical charge flowing past, voltage, the more energy you have to use. Okay, so makes sense. The rocks go through bushes on the side of the cliff, losing some energy in the process. The energy is used up to crush the bushes. The bushes are like resistors in a circuit, offering resistance to the electrical flow and converting it into other forms of energy. Okay, wow, I actually never realized how good of an explanation this is. It's actually kind of crazy. So, our rocks, amount of electrical charge, or voltage, difference in energy between one point in a circuit and another, and resistance, how much a component resists the flow of electrical energy. Boom, boom, boom. That kind of gets us started. So, what happens with our little circuit here and our LED getting overwhelmed is that our current is to, well, how would I say this? Current through the LED is 483 milliamps, while absolute maximum for the LED is 20 milliamps. So our current's too high. Current's way too high. The thing that we do about that is just like how you have your rocks going down the hill or going down your cliff, and you want less of that energy, you put some stuff in its way, or you put something in the way that's going to resist that force. So you put some sort of entity within your circuit that's going to reduce that current. That's what a resistor is, hence the name resistor. It's all about invoking the force of resistance. So the name for the flow of electricity is current. When current flows through a component like an LED resistor, there's an associated change of potential energy across the component voltage. The amount of voltage drop across a component depends on resistance, how much it restricts the flow of currents. This can be really important for making sure your components don't fry because they aren't able to support the current coming from your battery or power source, as we will soon see when it comes to parts like LEDs. So you can actually, so you can actually calculate the relationship between current, voltage, and resistance according to Ohm's law. So it's a mathematical relationship. Voltage equals the current times resistance. Pretty sure that's it, yeah. This little circle is nice because what you can do is it kind of shows you the mathematical relationships just based on how it's laid out. So if you can cover up, so you want to find the voltage, you cover up this V and it shows you the mathematical relationship from this to this. So if you cover up the V, these guys are side by side, so it tells you that current times resistance is how you get your voltage. If you cover up say you want to find your currents, you cover up the currents, and this shows you with the vertical that a current is voltage divided by resistance. And then you can do the same thing for resistance. Resistance is, if you cover that up, you can see that it's resistance is voltage divided by current. So but we're not going to worry about the math about this. We're not going to worry about the math as of right now. It is important, but it kind of sets us up for choosing the right little resistor. So basically, what this all means is that we have to incorporate a resistor between the LED and our and the current as it's currently being supplied by the power source. So I'm going to move this down, or I guess I'll just do that. So red, run our simulation, should work. Now we have to add the resistor. So we can just we can just go in here, take one, and just plop it down. That's kind of goofy looking, but I guess that works. No? Really? Okay. I know it's connected to the ground here, but I don't think it really matters which direction you have it connected to. Can I do this actually? I'm curious now. Resistor. So let's do this. I want to make this really obvious what's going on. So let me just kind of redo my wires here, because like things are kind of all over the place right now. So right now, this is our circuit where there's too much energy or too much current going to this. So what we're going to do is connect why can't oh stop simulation, that's why. We're going to connect our resistor to here. So now we can see the current's flowing from here through the resistor to the LED back down. Why is it not working? Hold on. If anyone in the chat has an idea, I'd be curious. I mean, worst case, I could just like, interesting. Worst case, we can just build the circuit as it's already shown. Because it shouldn't give us an issue that way. Unless I have, I might not have a strong enough resistor. That might be why. How do I change that? Yeah, okay, that's why. I don't have a strong enough resistor. It's annoying. 200. So you can see how the colors change on here. Let's see if someone probably... right. So change this value to 220. Okay, perfect. And yeah, someone actually just called that out too. Thank you, thank you. Yeah, so you have resistors of different strength. As you can see, like the color, there's color like coordination system to it all, or like a color labeling. I don't know. But you can see as I change the value of resistance here, the colors here change. think it's just 220 ohms, right? Yeah, I had it on K ohms. But yeah, so now I'm changing the value here because it says that you need a value to 220 ohms. And that should give you enough resistance. So now let's run this, see if it really, because when it's, yeah, when the current through the LED is 483 milliamps. Interesting. Unless it's just like the way that I have it hooked up. It could just be like a thing with the simulation. So let's do this. Let's delete that. Let's get this button out of here for now. Oh no, oops. Let's see if this works. This is a little tedious, but at least it kind of shows us how the simulation kind of thinks. There we go. Yeah, because I had stuff like overlapping on the same pin, which like you aren't really supposed to do with your actual Arduino, because you can't really like fit two little prongs and a wire into one little thing here. I mean, I guess if you might be able to make that work. I don't know, actually. Don't take my word on it. But yeah, so what we learned from that is you can't have like little prongs from two things within the same hole. Otherwise, it's going to yell at you, or it's just not going to work how you need it to. But yeah, so now we can see that this is working properly, right? So again, we can follow the energy. So the red goes through. This is our high power or our high potential energy, right? So the current travels through. Now the current is on this horizontal strip, gets connected to here, this wire. So now the current is on here, and it gets passed through the LED, through the anode, comes in through this strip, through the cathode, and it goes through this black wire to connect to the resistor here, which then goes down here. In fact, we could just get rid of this black wire if we really wanted to. We could just do that. And that should work. Boom. Okay, so again, we can see this pathway. Okay, so now, last but not least, we want to be able to control when this LED, plug in my laptops. We want to control when this LED is on or not. And we can use a button for that. We can use this push button. So now we're actually going to follow like the little schematic that it has here. We understand how everything works conceptually. I just wanted to build our way up to that. Now with that, let's go ahead and implement this. So let's get rid of here, get rid of here. So this is on E13 like it wanted. This is on E8 as it wanted. So you can see there's two sides of the breadboard. There's like this side of A and E, and then there's this side F to J. From what I understand, these are actually two distinct non-connected parts of the board, right? So you can see if I hover over here, this strip does not also highlight this strip because these are just separated. This like whole rectangular board here from A to E is distinct from this F to J. They're not connected together. I don't really know how the button actually works in terms of like how the energy flows. I think it goes from like here to here to here. And so I think it actually travels across the separate portion of the board. I think the reason why they do that is so that, so when the button's not pressed, this connection isn't made. So the button is just kind of sitting here. There's not a connection over here to eventually like complete from this leg to this leg. And because of that, the current just stops because there's not that continuous loop. But when you press the button, then it does connect in some way. I don't know, but it works something like that. I don't know the specifics, but that sounds about right. So anyways, we have this in place. So now let's go ahead and hook this up as it is instructing us. So we have the power connecting to the anode of the LED, right? This leg that has to, again, you can only flow one way in an LED. So it has to be this anode, this longer leg specifically. So the power goes through here, goes to the LED, goes out through this cathode, the shorter leg. And so we have it now connect to the button. This button, now this wire is connected to this metal strip here, which the button rests upon. Now, of course, the power is going to go through the button when we have it pressed. And it's going to come out this leg here, which is going to give the current through this metal strip here. And we want to get back to ground so we complete the circuit. So we're going to use our resistor right on this strip here. So it wants us to connect it to, again, it doesn't really matter where precisely, but just to follow along with this. As long as it's one of these holes, you connect it to ground, to this strip here. Then it's going to have to be, what is this, B8. B8. And again, if we run it right now, and press it, there we go. Our resistor is a little bit too strong. See, it's 1,000 ohms. The LED will still work, it'll just be kind of dim. But let's put it at the resistance that it recommends, 220. It'll be a little bit brighter now. There we go. Or a fair bit brighter. So there we go. Again, when the button is not pressed, it doesn't connect between these two. So when we do press it, though, it does connect so the current can flow from this leg all the way around to this leg, is how I understand it at least. Anyways, just know that when you press the button, you complete the circuit. And there we go. Boom. There it is. That's our first Arduino project. So is this easy enough to follow along with conceptually? Is there like any questions or anything of the sort on like how this works? Is it clear? Let me just go through the chat to see what's going on. Oh, nice. Are you following along with this? So let's see. So put the resistor on the plus lane. So here's the interesting thing. You can put the resistor either, it doesn't matter where in the circuit you put the resistor, from what I understand, or at least, is that how it works? Essentially, you can actually put the resistor before the anode or after the anode. So let's actually do that now. I'll show you. Arduino doesn't actually cover this, at least I don't know if they ever do. I haven't gone through the whole project book yet. I actually found this myself. But I'm going to switch the resistor around where the resistor is now like before the anode instead of being after it. And it should still work the exact same way. Wait, why is that not working? Oh, because this is not connected to power. That's why. There we go. Okay, so now it's connected to power. Boom. So it actually works no matter where you place it. Something to do with the nature of current. I read somewhere that in actuality, so they teach that current goes from higher energy to lower energy. But I think in the real world, it's actually that current flows from lower energy to higher energy. But that the mathematics work out the exact same way. Just like in one, if you think of it as going from lower energy to higher energy, there's like a lot of negative signs, I believe. But it all works out to the same answer. So people don't want to deal with a bunch of negative signs. So they just talk about it from higher energy to lower energy. Or higher potential energy to lower potential energy. I think it's that, and also I think the way that it was first conceived of, people understood it as going from higher potential energy to lower potential energy until like further experimentation and the like proved the opposite. But again, like mathematically, they're equivalent. So here, let me commutator in series and change resistance gradually. Oh, that's pretty cool actually. I didn't know that. Do the electrons flow from higher to lower and the current is opposite. Yeah, that something like that rings a bell, for sure. So please share the PDF. I don't know if I can, just because it's copyrighted. So I don't know if I can do that. So I'd rather be safe than sorry. But you can get that PDF with the Arduino project book. So, or the Arduino project kit. So current flow versus, so it's basically the same concept, but just different perspective on it. It sounds like, I'm guessing that the current flows in one direction, and then as a result, the electrons are going the other direction. If that makes any sense how I explained it. I guess it's just two different perspectives on the same phenomena, it sounds like. Yeah, I didn't know that either, that you could connect the resistors to the power node, until I was reading about that stuff. And I was like, oh, that's kind of crazy. There are some good electronics resources that I found, just explaining the real world practical stuff like that you don't really get taught or really explicitly explained to you. But yeah, so that's that. That's our first circuit. So big deal, big deal. Let's keep going. Let me swap this around again. So how we had it before I did the resistance thing, the resistor. There we go. So this should still work. Okay, so I already did this. And then here it is on an actual Arduino. Cool. Continue to the next lesson to learn how to add another button to the circuit. Now we'll build a series circuit. Let's do it. If it loads. Here we go. Build a series circuit. Let's do it. Series circuit. Once you've tired of pressing the button to turn the light on, it's time to shake things up by adding a second button. Ooh. How we getting? Oh boy, let's do it. This lesson, you'll connect buttons in series. Components in series come one after the other. They share a connection at one terminal. Check out the current diagram below showing the buttons in series. Okay, so in series just means right after the other, right? So we have, it's basically the same setup in terms of the schematic, right? You have your 5 volts, goes through the resistor, but instead of one button, it goes through 2. Then it goes to the LED, and then to ground. So yeah, and look at this. You can actually see that the schematic's actually kind of backwards, right? Because we have it set up to where the 5 volts goes to the LED, then the button, then the schematic, or then the resistor. But again, I guess it just doesn't matter. So add a button. So stop the power source. Thankfully, we're emulating. So now we have to set them up just like this. So I think how this works is when your buttons are in series, both of them have to be pressed for the current to be completed. So it's not good enough to just press one button. If you only press one, your LED is still not going to turn on. Both of them have to be pressed because the current relies on it. There's just only that one pathway for the current. Remember that buttons don't complete the current if they're not pressed. So let's go ahead and do this. Looks like we're moving this down to which ones? So 18, 13, 8. Okay. Move this down to 18, button on 13. So we move this. Again, we're just connecting the power to the anode. make it red so we can show that we're dealing with the power current. So now this strip, so the power goes through here, energizes this strip. Now it goes through the LED. So the current's now in this leg here. We want to get to this button here. So we're going to connect it to here. It goes from here, from here, then back through the resistor. Okay, so now, why do these look different? Oh, I guess I'm using a push button. Well, what is the difference? Yeah, that's weird. I guess it literally doesn't matter, but whatever. Okay, so now we're going to start simulation. Now again, if I push one button, like I'm doing now, you can see it's not working. I think if you hold shift down when you click it, so it stays pressed. So this is staying pressed down. Now when I press this, now the circuit's completed because both buttons are in place now. So now hold this down and boom. So these are both being like physically held down right now. That's why this is working. If I take just one of them off, circuit is incomplete. So yeah, I mean, pretty conceptually simple, I would say. Like it has all this text, but we get the point. Now we'll build a parallel circuit. So this is one where you're going to have two buttons again, but either of the buttons, you can only just press one and the circuit will be completed. So as it shows here, right? You have your energy going through resistor, your buttons, that's what we care about. If this one is pressed, the circuit completes here and it just goes down. If this one is pressed, the circuit completes this way. And everything works out. So it has this wiring scheme for it. So let's analyze this. Let's see why this works for both. I was actually helping a girl out with this in my coding club. She was interested in doing Arduino stuff. She looked at this, she just could not figure out what was going on. And I told her, like, did you like analyze it? She said no. She just kind of arbitrarily wired it, just following the picture without kind of thinking about like why this is wired in this way. So let's talk through it and kind of understand like why they chose this wiring setup and why it works precisely. Because it's pretty important, like I think, to kind of sit down, understand how things work before you implement it. And so once we went through that, she was perfectly good with it, and then she went on and started doing that for all of them, and she was perfect with it. So that's where we want to get to. Let's see. Oh, that's like Boolean. Okay. I didn't even think of it. I didn't think of conceptualizing it in that way. That is interesting. Okay, so going on. Let's do our let's see what exactly is going on here. How is this wired up in such a way where it successfully allows us to have parallel circuit? So let's look at, oh, it's just cut off like that. Okay. Okay, so we have the power coming in, boom, boom, boom. This goes through the LED. So really what we want to focus on, in fact, if I could do this would be fun. This would be a lot nicer, rather. So let me get what color do I want to use? Let's use blue because it's contrasting. So the power goes through here, goes through here. Okay, so now we reach this wire right here, and this is where things start to split. So how do we get from one button to the next? Let's see. So remember that if neither button is pressed at this point, the circuit just stops here, right? The circuit just stops. But upon pressing a button, let's say we press this one here. If we press that one, Then we can see that the current is going to flow, boom, 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 to here, and then goes down to here, goes to the resistor, and it goes to ground that way. So let's do another one. What is it? Custom pen. How do I custom? Let's do line. Why not? So again, now here, if we press this button now, it's going to travel from, because remember, it wants to get, the circuit kind of knows where it has to go because it's just following the inclination of like where the low energy is, right? So if we press this button now, it's going to see, okay, well, how do I get from here to here? It's kind of like a maze almost. We can see that this wire is connected to this strip, which goes from here up to here, up to here, and then it follows down to the resistor. So a little bit of a mess looking at it, but we'll do it one by one. So let's get this one first. We're going to wire this one up. So we go from here to here to here, here, here. So we'll wire that. So we have our two buttons. They're still in the same places, right? Yeah, E13, E18, E8. Okay. We just have to delete the wires. Well, actually, no. That one should. I think that's exactly the same, isn't it? Just about. We just have to right, since these buttons are going to be independent, we have to connect this leg to the resistor directly instead of like having it traverse through here. So we have to connect. We just have to make this wire longer is all. Or we just have to place it like right here, essentially. So boom. So that's this one done, right? That's easy as that. We only have to change one thing because this was already like in place. So now to get the second one, we have to wire it like this. So again, we're starting here. We press this button. We start here, and it goes from here, here, up through here, over, down. So we have to do this now. So energy is coming from here, setting this one up. We have to connect it to this leg now. So we connect it from here to here. And right from there, that's the only wire we had to add, because now it's connected to this leg here, goes through. This leg is already on the same strip as the resistor. So now if we power it, start simulation. We press this one, boom, it works. We press this one, all right, just by itself, right? Just the one button. It's not in series, so we don't have to have both of them pressed. So that works there. We press this one, that one works. Easy as that. Yeah, connecting parallel makes an OR. Yeah, that's I mean, it makes sense to think of it as Boolean, but I just never thought to apply it in that way. I never like went to like and or gates or anything like that. I think I actually only did the first few projects in Arduino. I think I only got up to the second project, but I do find this stuff fascinating. I'm going to be in the makerspace all the time this semester. I know that for a fact. There's also like a co-op near here. Not a co-op. What is it? It's like a nonprofit that it's a nonprofit hackerspace where you can do everything in a makerspace, but they also teach you like machining skills, like soldering, all sorts of electronic stuff. They have a huge, huge room of all sorts of electronic components and meters and like anything you can imagine. Huge room, and anyone can come in and just use it. It's really, really cool. I plan on like learning how to solder and do electronics projects there, and then like do Arduino stuff at school, and from there just become an electronics fanatic, really. But yeah, anyways, I don't know. I love this stuff. I find it really fascinating, at least what I've done of it so far. And so there we go. So you can expand this project a number of ways. Putting 3 or 4 buttons in series, trying to put 3 or 4 buttons in parallel, like in parallel in series. Think about why each circuit behaves the way that it does. Do we want to do that right now? I guess that's really the question. Nah. Let's go on and see I'd rather introduce new concepts. Because this is intro to Arduino. We got the gist of series and parallel by this point. I'll leave this to an exercise for the viewers. Well, look at that. It's going to teach us about Ohm's law then. We already covered it. Do we really care about this in terms of just our basic intro? I mean, it's something that you should know if you want to go down to study this, or not even study, just go down to do your own little Arduino projects yourself. So, yeah, let's see what it has to say. We can just skip through it yeah, so oh, cool. Here's that little pyramid thing I was talking about. I actually like this one better. Actually, can that fit my notes easily? I'm going to snag it. I mean, this one is... yeah, I guess that works. I mean, this one is a little bit... it's already within there. I don't know. I like this because it's like all-encompassing. Or is this one like says the same thing, but it's a little bit more busy? Okay, so a multimeter. Take a look at the circuit in the work plane. We're using a device called a multimeter to show us how much current is flowing through a resistor and LED. Multimeter is a tool that can verify the amount of resistance, current, or voltage in your circuit. You'll see how the measurement of the multimeter window changes as you increase and decrease the value of the resistor. Okay, cool. So when measuring amperage, current in your circuit, so when we measure the current, values will be in the milliamp range. 1 milliamp is 0.001 amp, 1,000th of an amp. Actually, just I was teaching myself French a while ago, and this is more of an aside. I didn't know that milli was the prefix meaning 1,000. Interesting. I mean, you know like million, but million is also like a Latin-based word for just million, whereas milli in and of itself is 1,000. I guess that's because I'm not surrounded by the metric system. I don't really see milli pop up too much as a measurement prefix. I guess there's like millimeters, but I never really thought about it. Anyways, 13.5 milliamps for this popped up. So simulate the circuit. Make sure the multimeter tool is current mode. Okay, so yeah, we can see that. How does the brightness of the LED change with the amount of current flowing through it? So this is the current, right? We see we have a resistor active here. If we put this down to 0, and we get the full current milliamps, right? This is what it told us earlier when we hovered over it. When we had no resistance going through, we had 483. But as we turn up the resistance, oh man, I wish we could like cycle through it. That way we could see the current value also change. 5, 4, 5, 6. So we can see that the current's intensity is going down as well. So 220 said maximum allowable was something like that. I don't know. It said I think it said that the maximum allowable current through this LED without making it like without frying it was 20 milliamps. So let's see if we can get away with that. So what would be like 10? So you can see it's still like freaking out. 30. No, it's not freaking out anymore. The recommended maximum is 20. Okay, so I guess they just, maybe when it's over, I don't know. Their little animation obviously isn't reality. So anyways, I was just curious about that. 220. Continue on to the next step. Calculating current flow. Okay, so let's do a little bit of math here. See if we can do some basic algebra. Lord help me. So we want to find the current. So current equals, what was it? We had a little square, right? Voltage on top. Then current resistance. So we want to find current, then it's going to be voltage divided by resistance. So if we have that, that would be 3 volts divided by 220 ohms. You need to use a low in the meantime. But like dimensional analysis, how does that, I wonder what the ratio is. Like, how does that work, actually? My math skills, I am getting myself up on. Long story short, I had a before tech, before engineering, classically composer. Told myself that I knew I always wanted to be that. Told myself I would never have to learn math, so I just completely ignored, retain, even learning a lot of important concepts first time through. So I just learned the concept of dimensional analysis the other day as I'm going through Algebra 1. Pretty cool. But makes me wonder, like, how do you do that? I'm interested. Like, where would your amperes come here? Like, come in with this, right? So I guess you just ignore. You just ignore the values. Not really. I don't know. Someone tell me in the chat if you could, because I'm kind of curious how that works out. Like, how do these units balance out, or do you just ignore them? And if you ignore them, why do you ignore them? When do units come into place? So I guess 3 over 220. What would that be? Do I know any math tricks off the top of my head? No, I'm just gonna be lazy. In fact, let's do calculator. Just to give a nice visual. 3 divided by 220. 0.013. But again, it's like, how do you know? Is that directly to amps? I don't know. That'd be equal to 0.013, just about. So yeah, if someone in the chat knows, I would really be curious about that, because I don't know off the top of my head. Bonjour, bonjour. J'aime beaucoup le français en général et le langue du français. There we go. I love the French, and I love the French language. Probably butchered that, but that's okay. Let's see. Value back to 220 ohms. So is it just that, like, an amp is, I guess so. I guess that, like, resistance is just fundamentally tied to the ampere, something like that. I've never really thought about that. That's interesting. Like, not like fundamentally it's not, but I guess we just treat it that way, right? I don't know. If someone knows in the chat, I'd be curious about that. So I never really thought about that. You should have 3. You find that I equals, yes. Okay, so through 13.5 milliamps. So we can see how the math works out here, right? So we have this resistor that's 220 ohms. So yeah, that's where these numbers are coming from. I should have specified that too. So the resistor, the one that we have here, we can see it's a value of 220. That's where this comes in. And then the 3 for the voltage, where is that coming from? Why is it? Because you have 5 volts coming through here, right? Oh, because the resistor, right. So the resistor is acting on the voltage. That's what's so weird about it, though, is that it's not like a straight line, right? Because you would think that, like, when you start here, you would think that the voltage would be 5 volts. And then, boom, once it hits this resistor, then it would be diluted. Well, that's not the case. Again, you can run it. It's running through backwards. Let's say it's running through backwards, like how we were talking about before, right? Like, it's running through backwards. So you could see that, okay, so, but I don't know, it's just weird. Like, it kind of affects the system as a whole instead of affecting it at any one point, at least from how I understand it. Again, I'm still pretty new to all this with circuits and all of that. So I'm guessing that is it that the resistance is affecting the currents, and because of that, but that's what's weird, is that, if the resistance is being accounted for right here, right at 220. So why wouldn't this be 5? You know, and then that factors into affecting the thing. I don't know. I'm asking myself a lot of questions that I will have to experiment with because I haven't delved into this. Oh wait, okay, here we go. It's, okay. So 5 volts are supplied, and then there's 2 volts being used by the LED. It looks like, because this symbol is for the LED, right? I'm pretty sure it was. In fact, we can bust out our handy dandy. It has these symbols like within this Tinkercad as well, but I don't feel like going back through all that stuff. So let's see. If we scroll upwards, it has all of our components, and it'll have the little schematic symbols for it. That should be the LED, right? Okay, so the LED here. Okay, so that's why. Interesting. So the LED uses 2 volts. The resistor uses 3 of the volts. Okay, so that's why we have this 3 volts here. Well, okay. I guess that makes sense, yeah. I'm just thinking like, well, why is it the 3 volts of the resistor that we care about rather than like the 2 volts of the LED, like in terms of the overall system of this? I don't know. Lots of questions. But it works. It just works. I'll have to sit down with that and think about it because now I'm curious. Okay, but anyways, again, intro. So we don't really care about that. We just need to have things work. So there we go. We built our circuit. Back to project page. Build a simple circuit. Oh, we did all that. Okay. So we did project 1 and get to know your tools. Let's keep going through. Again, we only really care about the Arduino stuff right now. Project 2, spaceship interface. Some more water in me. Keep up on the chat. Moi aussi. I love French, man. It's a beautiful language. I haven't actively studied it in quite a while, though. I got pretty good, though. I was able to... There's this great podcast series called Inner French. It's for like intermediate French. It's a podcast entirely in French. You have like 30-minute long episodes and all sorts of stuff. Like one's on like how to learn the language, best methods for doing so. And others on like robots and how they integrate in society. I was able to listen through those and understand like 85% of what was being said. Like they're each like half-hour long episodes too. It's pretty interesting. Language learning I love. In fact, in a perfect world, I think I would study history, language, culture, all that, instead of I mean, I still love engineering, don't get me wrong. Super, super passionate about it. But that sort of stuff takes my heart a little tiny bit more. But I already had one career in the humanities, which, did well. But I'm ready for something a little bit cushier in terms of like after you put all the work in at this point. Thankfully, I have a lot of passions, so it works out. Anyways, what are we talking about here? So, no, I don't want project 3. I want project 2. Here we go. This project, your Arduino is going to start in a science fiction movie. Now that you understand the basics of electronics, it's time to start controlling things with the Arduino. In this project, the control panel lights up when you press a button. This project uses digital inputs and outputs, variables, and basic Arduino code. Okay, so we're going to start using some basic programming. Fun stuff. Arduino code it's basically C++. It's like, it's C++. But I think there's like some additional little tiny concepts that they've introduced into it, but it's C++. So if you know any C++, it's going to look familiar. If you don't know any, we can walk through it, like the basics. It's really basic what they have you do. If you don't know any code at all, we can still walk through it. It's super basic what they have you do in this project. Let's see. So in this project, your Arduino is going to start. Yeah, we saw that already. So what are we doing? So we're just going to have like blinking LEDs that blink on their own, from what I remember. Right, so push button. So we have 3 LEDs here. We have this LED, this LED, this LED. We need resistors for all of them. These are going to be in, is that right to say that they're in parallel? I guess so, yeah. With a 10K ohm resistor, interesting, okay. So we have our voltage coming through. We have a button that we're going to push. What does that do though? Because you can see that in the schematic. Let me draw here. So this is how I'm looking at it. So you have your voltage, it goes through to your button, and it goes through to this resistor directly, and it just goes to ground. Now you can see that we have these buttons hooked up on the right-hand side, or no, these LEDs hooked up, but they're not getting power from the voltage here. They're getting power from this. Is it power that they're getting from this this digital pin? And it goes through here, and then it goes to ground ultimately. And then it's the same for like the rest of these buttons, these 2 other buttons. Okay, well, this number 2 is hooked up to this resistor as well. So that's what is going on here, and it's interesting. I don't remember how this one works. Like I said, it's helpful to understand what it is that you're actually doing, like how your circuit functions. That way you're just not blindly plugging things in just because it tells you to. You want to understand what's going on. So that's interesting. Let's read what it says. I'm curious what it says. So you'll be using the Arduino to control the communication between inputs and outputs. A green LED will be on until you press a button. Okay, that's some pretty important context. A green LED will be on until you press a button. When the Arduino gets a signal from the button, the green light will turn off and 2 other lights will start blinking. Okay, so you push the button. So when you don't push the button, the green is going to be on. Okay. How does that connect like that? Because these seem like they're set up pretty independently. So I'm guessing, oh, is it that? Okay. So I'm guessing it's something like you push the button. When the button isn't pushed, because remember, when a button isn't pushed, the circuit isn't completed. But your circuit doesn't travel through if your button is not pushed. So what I'm guessing is happening is that circuit's not completed. So there's this part to the button, like there's this number 2, this digital pin 2. When the button isn't pressed, then it's going to run some code, depending on when the button's pressed and when it's not pressed, from what I remember. The button's not pressed, but I think it's this green button that like the Arduino tells like, hey, I'm going to light you up. When the button is pressed, however, then you have a physical change that's then you have a change that's informed by this pin number 2. And when this pin number 2 is activated by pressing the button, then that gives the direction of like, hey, stop supplying power to the green, start supplying power to the other 2 buttons. So I'm pretty sure that's how that works. So again, when the button's not pressed, this digital pin 2 is not activated. So you're in one state of the circuit, I guess you could say. In that initial state, the non-pressed button state, digital 2 isn't getting activated, so it's not communicating to pins 5 and 3 to do something else. Instead, pin 4 has just been communicated to let this button be lit. When you press the button, pin 2 is activated, so that gives an alternate set of instructions for these other 2 buttons to be, I think they have these, well, no, for other 2 buttons to then be lit up and to stop supplying power to that green button. I think that's what's going on. Let's see. Let's keep reading. Take a look at the circuit diagram below. When the button is not pressed, the voltage at digital pin 2 is pulled down to ground, 0 volts. Okay, so let's take a look at that. So when the button is not pressed, the voltage at digital pin 2 is pulled down to ground. Oh, okay, so there's already power going through here. Okay, so I was wrong with that. When it is pressed, pin 2 sees 5 volts. Okay, so pin 2 is going to be, I guess, just measuring the volts. I don't know. I can just keep reading, but I like thinking out loud like this, and just trying to like finish it myself at first because it helps me just, I don't know, helps me work through it and just kind of understand things in a more holistic way once I finally do get the right answer. When it is pressed, pin 2 sees 5 volts. Reading the voltage on pin 2 is how you will determine whether or not the button is pressed. Okay. Oh, so I mean, I basically was right then, right? When the button is pushed, like pin 2 gets differing information based on whether the button is pushed or not. And that's going to then signal to these buttons, that's going to signal to these LEDs which ones to turn on or off. So you can also see that the 3 LEDs are connected to digital pins, right? As we see here on the right-hand side, these are connected to these digital pins over here, which will act as output pins. So those will, okay, so 2 is an input pin because it's going to be gauging that voltage. 5, 3, 4, and 5 are output pins. Okay, this is making sense. So we need 1 push button, 2 red LEDs, 1 green LED, 220 ohm resistor, 10K ohm resistor. I wonder why that 10K ohm is being used. That's the thing that I don't understand. Okay, so let's, oh, wow, that's a low resolution image. Let's see what's going on here. Is it low resolution or is it just like pixel art almost? I don't know. Anyways, because look at that shading. It looks like a Sega Genesis game or like an SNES. Anyways, so let's figure out what's going on here in terms of like the actual board. So again, that pin 2 is going to be pretty crucial because that's going to be that's what's going to determine whether we give like one set of directions or another set of directions. So this pin 2 right here, it's hooked up to ground, as we can see with this resistor, which then ultimately completes the circuit as we go through. So nothing new. But this pin 2 here is hooked up to this, which goes to ground. We can see that we have power coming from there, as we know, because we're going to ultimately make our way to this button too. We're going to make our way to this button because when this button is pressed, then pin 2 is going to get different information. So okay, hold on. Okay. Let me explain that a little bit better. So we're going to have current coming through here, down here, to this button. Now, when the button is not pressed, we don't have a circuit there, right? The circuit's not complete, so we don't have current coming through the button, right? However, this pin 2 is going to be this pin 2 is going to give a reading based on like what's coming in through this metal strip here. If there's no current coming through, like because the button's not pressed, if there's no current coming through, then it's gonna take the lack of current here and read that as 0. But then how does it go to the resistor then? See what I'm saying? It's something like that. Somehow it's still able to go through the resistor though. So anyways, once you press the button finally, so power's coming through, get through the button. You press the button, now it reads the 5 volts. And now it's so it can differentiate between 0 volts and 5 volts. Or we can supply either 0 or 5 volts, right? And so it'll go through the resistor and complete the circuit there. So that's happening. But then we have, So I guess this is like one separate circuit from the LEDs. Am I understanding that right? Like conceptually? Like these are three, like the button, I guess there's different circuits going on, right? Or no? Because it seems like the pin 2 circuit carries the information to the program, which is then going to run code that affects the circuits of the first LED, the second LED, and the third LED. So, yeah. So now we have the button pressed. So let's think about this green one now. So we said that when there is no current, when the digital pin 2 reads no current, when the button is not pressed, then this digital pin, right, this is an output pin, so this is going to supply power to this LED, and it's going to complete the circuit by going to ground, right? When you press the button, then this is not going to supply power. So the button is, so this LED is off, but these two will supply powers to the other two LEDs. So, yeah, so this, like this pin 2, it's kind of like, how would I want to say it? It's not directly affecting the LEDs in any way. It's affecting, determined based on what it's sensing, whether it's 0 volts or 5 volts. It's affecting whether these pins provide power or not, and from there affects the LEDs, right? So it indirectly affects the LEDs. Why you need that 10 volt there, I don't. I guess it's to handle. I guess it must be to handle all of the voltage coming from like the digital pins here, to balance out the entire circuit. But that's kind of interesting. Maybe, again, that's just a guess. I don't know why. Some of this stuff, you just kind of accept it. You don't really have to do all this thinking like I'm doing, but it's definitely helpful to do. Hopping off. Yeah, thank you so much for coming on and watching. Yeah, I hope this has sparked people's curiosity about Arduino as a whole. I'm still relatively new to it, but I loved it. Like every single session I've had with doing Arduino stuff, I've really found it fascinating. So anywho, I think we have enough of an understanding to get underway with it. So let's not just do it blindly. Let's see if it kind of walks us through what's going on here. So digital pins have only two possible states: when there's voltage on an input pin and when there's not voltage on an input pin. Okay, so like we said with this terminal 2, or this digital pin like number 2, that's exactly what we're looking for. If there's voltage or if there's not voltage, so that's going to affect how the LEDs shine. This kind of input is normally called digital, or sometimes binary, for two states. These states are commonly referred to as high and low. High is the same as saying there's voltage here. Low means there's no voltage on this pin. When you turn on an output pin high using a command called digital write, that's where our code comes in. You're turning it on. The voltage between the pin and ground will measure 5 volts. Right, okay. The voltage between the pin and ground will measure 5 volts. When you turn an output pin low, you're turning it off. So we'll see what this means. This gets into it when we're writing the code. So these are the digital pins that we want to use. We're going to be using this 2 and 3, 4, and 5. So in the Arduino code, you'll have to configure each pin that you want to use as either an input or an output. When the pins are outputs, you can turn on components like LEDs. If you set the pins as inputs, you can check if a switch is being pressed or not. Okay, so like here. So we have this pin 3, which is being used for output, like we said in that image here, right? This pin 3 is being used for output, or yeah, because it's going to be supplying power to that LED. So 4 and 5 are the same thing, right? 4 and 5 are using for output as well, supply power to the LEDs, or current. And then pin 2 is input, like we talked about. Okay, so now we can go to Building the circuit. Connect the 5-volt pin on the Arduino to the red voltage rail on the breadboard. Okay, so yeah, I like how they do this too. Like because you always need this. Like you need this for your circuit to work. The setup of voltage, ground. So I like how they start with that because you always need that in place. Ground. Let's color code these properly, or at least for better understanding. So red there, black here for ground. Okay, so we're going to add the 3 LEDs. Right? Okay. What pins does it want? 6, 10, 14. Okay, so 6 plus 4. Is that on row E? Yes. Can I copy and paste? Oh, yes. 14. No, 14. Okay. Then we're adding, and we already know this, right? So again, here's our anodes. That's where our positive connections have to go. So we'll go from 3 to, let's say they put on this second one here. Change that to red. And we just add a resistor, right? We need that 220 ohm resistor. Do that. In fact, let's, while we have these, let's just set these up. Right, so I'm putting all these resistors in place on the cathodes of each of these individual LEDs. Then we just have to, we're going to be using those digital pins 3, 4, and 5, right? So let's do that now. 3, 4, and 5. So look at the image. We are perfectly right. Well, these are moved down. Doesn't matter which one you put it on, honestly. Because again, it's this vertical strip here that carries the power. It doesn't matter which of these pins you put it on, so long as it's not like the same pin as this LED. Because again, that's just like practically unfeasible. But I'll do this. I'll do it just to match the picture. Okay, so we have that. Let's change the color of this to green as we need it. Okay, so we did all that. So now let's look at our code. LED built-in. I was going to say, we're not telling anything to the pins. I think this is just like, right, so it says like C++ code, right? I don't know if this is like, we might have to edit this because we need the pin modes to be specified. Place the button on the breadboard just as you did in the previous project. Attach. Let's get this out of the way. We won't worry about the code for now. Place the button on the breadboard just as you did in the previous project. Attach one side to power and the other side to digital pin 2 on the Arduino. I'm surprised I don't have a breadboard 1. Whoa, hold on. I want to go back to add the push button. Oh, okay. Only got about 10 minutes left. I want to see if we can finish this in time. But yeah, for sure. Thank you guys for being here and learning alongside me. It's been a lot of fun. I always enjoy these streams. Always a good time. But with that, we have 10 minutes left. I mean, if there's any questions or like anyone has, or like any final points of discussion, go ahead and drop them in the chat. Like any final thoughts, anything like that. But I want to see if we can get this done for the next couple minutes. So how do we have that? We have that button. They put it on E20. And then I think we want to connect to the leg here, right? Right. Uses a green wire, I guess, for input. Yeah, I guess that makes sense. You want to have a contrasting color because it's not providing power, but it's not connected to ground either. Can I bend this? Please tell me that you can bend these. I swear you can. Why? There we go. Okay, that way we can see what's going on. There we go. I like that a lot more. Not a lot more, but enough. Okay, so then we have to connect that 10K resistor to, hello, resistor, okay. Connect that to this here. Oh wait, actually no, just, really. That has to be connected to ground. Okay, so I have to push that up one. Yeah, because I can't have this like in the same thing. Here we go. Okay, glad that works now. Because you have to push on that. Yeah, okay. So we have that. This has to be 10K ohms. So this should be set up now. I mean, it's not going to do anything because we don't have the we don't have any code telling the buttons to light up. We don't have any code telling the terminal 2 to do anything when it detects different voltages. But if we were to hook up a multimeter, we should be able to check that the voltage is different. In fact, can we do that? You know, I don't really remember how to wire it up as of right now. Oh, I'm sure it's pretty easy. Let's see if I can do it in like 10 seconds, then we'll mess around with it. But if not, then no. So if we do, oh my goodness, I don't want that. We do this. No? Oh, I'm looking for voltage. Current. That's weird. Why is it not? Oh, probably because I'm just putting it straight to there. Oh, this is a mess. I'm sure if I sat with it, I'd figure it out in like a minute, but I don't feel like dealing with that. There we go. Okay, so anyways, we have that in place. Oh, wait, no, I didn't have it wired exactly right. Because what is that? It's going to power? Oh, okay, right. Okay, yeah, I didn't have it wired correctly before. Okay, that makes sense. This lesson you learn how to write the code. I mean, we're gonna drop in the code really quick. I'm gonna walk you through it super quickly. Code comments. Well, let me check the chat. I think at this point we can kind of end it because we've covered quite a good bit. We definitely got our intro to Arduino down, so I'm happy about that. I don't know. It's definitely fun stuff. I would see if you have like a makerspace at your school or anything of the sort, or just an electronics lab to continue playing around with this stuff. Or, I mean, just use the Tinkercad as well. Let me drop this in the chat, actually. Super cool website. So happy it exists because, I mean, I could buy an Arduino, but I don't know. I like having that. I'm sure I will at one point too, but I don't know. My school is kind of my place for Arduino. That's where I do most of it at. So, and I like doing it with other people and the like. So, I don't know. Fun stuff though. But yeah, this is Arduino. Intro to Arduino. Got some of the basics, fundamentals in place. Built our own circuit. We built a couple of circuits actually. In fact, we built what? We built the LED with the buttons in parallel, LED with the buttons in series, and then we learned a bit about this digital pins and the like. So, but yeah, just keep going through this if this is interesting to you. Super fun stuff. I love it. But okay. If there's any questions you'd like in the chat, by all means drop them, but I think we are going to bring things to a close here. So I'll sit here for another minute or so. But yeah, thank you all for coming. Yeah, merci beaucoup. Thank you. I appreciate it. So always fun stuff. Always appreciate you guys coming out, watching these. So I have some regulars now, people that come up to my streams, which is kind of nice. My own little MLH fan base. Interesting to think about. It's cool stuff. Anywho, that's that. Enjoy for all you going back to school. Have a good return to school, good semester, all that fun stuff. And with that, enjoy the rest of Global Hack Week. I will be doing the Chrome Dino stream, actually. In fact, let's see what's coming up after me. Let me hook up on my Google Doc. So we have building a sticker database with Cecilia coming up in just 2 minutes. So definitely be on the lookout for that. Look in the Discord, all that fun stuff. So without further ado, have a good one, everyone.